many of you here, given it's a Monday, and last week it was like awful, and apparently there's some light rail industrial action. So clearly none of you get the light rail. Is that right? Or did they fix it? No. You have to get a bus. My God, how will you survive? All right, we'll definitely have to take it easy today after your traumatic morning. All right, I did warn you guys. We suffered a lot this term in the sense of the pace we went through some of this content, I think. And the reason we do that is so now people have a couple of weeks to take a breath after assignment 1, focus on assignment 2 without the introduction of new topics right at the end of term before being slammed by the final exam. Does that make sense? So once again today, what are we going to do? Actually, well, the slides at the end, what we're going to do. I got a pretty cool lecture lined up, I think. So the first thing we're going to do is go back and do my experience. You would have got the email this morning, I think. Is that right? They were really late this term. I don't know why. I don't think they're usually in week 9. So we'll talk about my experience and why it's important. Then from 12, I think around 12, Ravine De Silva, who's a colleague of Angela and I's in the school, he runs the ICPC team for UNSW. He'll talk all about it, but it's the International Competition of Programming Challenges. Is that right? Have you done it, Tim? No, you're just nodding. So basically, UNSW, in CSE, we are some of the highest performing teams in this international challenge. He was just in Egypt this year with the UNSW team, and it's competitive programming. It's crazy. He'll come and show you what it's all about, and he was like, "Oh, can I talk about it for 5 minutes?" And I was like, "Why don't you come and like do some competitive programming?" So I don't know what it's going to look like, but we'll talk about the exam. God. Yeah, we'll talk about the exam. We'll talk about it. So Ravine's going to come talk about ICPC, and there's basically 2 divisions, one that are like hyper competitive and one that's a lot more open. So if you find it interesting, you can join his teams. Basically then we'll be going through revision, demos, and Kahoots. We'll talk about the exam in detail next week, I think, but we can talk about it a little bit today. Okay, but really importantly to kick us off is my experience. I ask for a lot of feedback in this course, and I think a lot of the tutors ask for a lot of feedback. They send around forms and things. You guys are chatterboxes today. What's going on? You don't even look like 1511191 students. You're too happy. Maybe we need to go harder. So we ask for a lot of feedback. You know, I've got my QR codes at the end of every lecture, and that feedback just comes to me. And your tutor's feedback goes to them. I don't see it, for example. However, as you may know if you've done some courses here before, the university runs their own really large-scale feedback system called MyExperience. And I can completely understand why you might get sick of doing these forms, right? But they are really, really important. Let me talk a few reasons why they're really important, because I know what it's like. You only do MyExperience for courses you hate, right? That's how it goes. Complaints. So the thing is, 15111911, this course requires a huge amount of resources to run. You can see we've got 3 paid tutors every lecture. We have, think of all the help session tutors. You got 2 tutors in your tut lab. We have 60 tutorials this term. It's a massive amount of resources. One of the reasons why we're able to get that resource is A, because we think you deserve it, but B, because we have really good MyExperience results. Well, I'm not trying to say that you need to say yes to keep the resources, but what I'm trying to say is it helps provide evidence for the university and for us when we say, hey, we want to try something new like we did with the lecture streaming setup this term, which I think has gone really well. One of the reasons we're able to do those things and ask for more money is because we get good responses on our MyExperience. Not necessarily, but the response rate is really high. And the results are quite good, let's be honest. So if you want more courses like the good ones, please do fill out the MyExperience for those courses and say that, yeah, that I had a good time and whatever. And if you want less courses like the bad ones, MyExperience really, really does matter. It might not be immediate, you might not get to see it, but by the time you're in your 2nd and 3rd year, hopefully the school in which you're studying has improved because of your MyExperience results. Okay, that's enough rambling on about it. They're completely anonymous, cannot be identified. We only get the results after the exam, so I can't retaliate and which I think is funny. Set a really difficult exam because I didn't like in my experience the results. And it's run by the university, not by us or the school or the faculty. And I usually do a few MyExperience completion tiers. So this is just completion rates. So if more than 70% of you complete MyExperience, we can do like a bonus lecture with some of the tutors. I don't know what, like a live stream or some form. You can dictate it. I think I used to have like 65, 75, 85. And then one of them was that I would do a question 12 exam question like live streamed, which I really kind of don't want to do, but maybe we could do something like that. And we've never hit more than 80% response rate. So you can, I don't know, dictate what we would do if we hit that. So how do you actually do MyExperience? You would have got an email this morning, and you can just click the links, I think, and follow it through. Or I've put 2 QR codes up here. So for the first 10 minutes, we're just going to do MyExperience. So scan the right one. I know, big challenge here, which course you enrolled in. Keep in mind, if you've opted into the 1511 assessment, you still have to do the 19, you're still enrolled in 1911. And I think it's only going to let you into the right one. So you can either go through your email or scan the QR code. And if you're online, I guess go to your email. Oh, it's up. Oh, yeah, I guess they can scan. But if they're watching on their phone, they'll figure it out. You guys are smart. All right, now we need to play some of that chill music. Wait, we can do that, the Kahoot music. That's a good idea. Oh no, spoilers. How do I do it? No, then they'll sue me. What if I just do this? But I don't want you to see it. I don't want anyone to join it. Oh God. Disaster. Yeah, this is a previous one. But I still don't want people to... You should be doing MyExperience, not Kahoot. All right. Yay! Let me know when you start completing it and we'll move on. But yeah, fair warning, we'll be driving MyExperience really hard over the next 2 weeks. So just please complete it so we can get off your backs. What do I do now? Coffee. I've already had 3 shots. And then I already made one at home this morning. So I had to read up all on the US news. Anyone a politician head here? Yeah, very exciting. The world's best reality TV show, the US government. Oh yeah, they don't. Oh yeah, fine. They don't really need them, but I will do it. What? Oh yeah. All right, it'll be 5 minutes. You know what we should do as well? 23 minutes late. You had a meeting. About astrophysics, he reckons. Yeah. Sure. What, my experience? Is it still going? How long are these things now? Gonna find I put a massive mirror at the back of the lecture room, checking what everyone types. Is anyone done? One person? You guys still doing it? Who needs more time? A few more people? Yeah, sure. Just do 1511. Started. Don't do the others yet. Screw them. What do you mean, 1911? No, you can only do one. Yeah, please. Please, please. All right, if you're done with my experience, you can jump over to the Kahoot to dictate what it is we revise for the first 40 minutes. But otherwise, you can finish my experience. Okay, John? Oh, for the stream. Yeah, yeah, yeah. I think I need to do it, right? You can just put brackets. Ah, yeah, you should be able to add yourself then. Yeah, you're right. Good point. All right, are we starting this Kahoot? What are we doing? Where's everyone up to? Is everyone done my experience? All right, I'm going to start this Kahoot. No? All right, joined? All right, let's go. It's the same Kahoot as the other day. It's just the topics that we want to revise. I'm just going to finish this. I'm not waiting for everyone to do that. Okay, it looks like demos won out with multiple concepts, followed by linked lists and a linked list demo actually, which is 40%. So actually linked lists are equal with demo. So should we do mostly a linked list demo, but with some other stuff in there? Does that sound good? Nested linked lists. Do the assignment. I get what you mean. I get what you mean. All right. So Jay, what you're saying is in the linked list nodes, it's not just an int, it's a struct. Yeah. All right. Yeah, we could. Yeah. Pet boarding house or something like that. Yeah. Okay. Yeah, we could do something like that for sure. I'll think exactly what we do. Maybe we can do something like. Anyone got any examples? Any ideas? Good chat. All right. To get started, I'm going to start off with the node. Now, what we're saying is, which I agree with, to make it a bit more complex. Oh, we're getting rid of that. That shouldn't be there. What we're saying is rather than just storing an integer or a simple data type, inside the node of the linked list elements, we'll store a struct. Okay? So that means we need to declare that struct elsewhere. So we do need to think about what it is that we're building here. John, Tim, Angela, any ideas? Linked lists? Any ideas? Wouldn't that just be a character? Stick to astrophysics. I'm just kidding. I mean, that's something we can definitely talk through, but let's get started with an idea here. I'm just blanking on an idea, and then we can talk about it as an example. Bookshelf? All right, let's do bookshelf. Does that sound good? Nerds. No, kidding. All right. So then the element we would be storing is a book itself. So a book could have um, a a title. Maybe it could have page length or something. What else does a book have? Oh, an ISBN. Anything else? Oh yeah, category. Genre, category. Could that be an enum? Like horror. It should be. Remind me that so this is like that. That is lowercase, and then these are capital. Horror. Whoops. Horror. Crime. What else is good? Romance. Comedy. That'll do. And then here we can have something like that. How's this looking? So in the node itself, what would I have? So even though this is a more complex node type, because we're storing a book, what would be inside of the node? Struct book, yeah. I think we can just call it that. Or we can call it data maybe. Keep it consistent. That looks good to me. And then a node still contains a pointer to the next node in the linked list. And each node contains data, but the data is, in this case, a book, which has a title, some data that you can think about other things that could be there. And maybe what we can do to speak to both your points is like insert books in the bookshelf, but when they go in, they have to go in a particular order. So by genre, then by title, something like that, which is a cool sort of problem. And if you put a new book in, you've got to put it in the right spot and rearrange all the other books. That's actually kind of a cool demo. All right, so let's think about what we need here. You guys tell me how sort of in-depth you want to go. Do we want to write all the functions from scratch, or do we want to borrow some from the previous linked list code? From scratch? All right, let's do it. So the goal, again, before you write a program, right, I think one of the things that 1511 sets you up for is that the problems you solve are very constrained and very defined. Like we tell you, write a function that does exactly this. And you get used to that. And then you go off to the real world and you realize it doesn't work like that. You need to come up with the problem and the constraints. So we need to think about what it is are we actually trying to do and what functions do we need to make. So the overall idea of the program, a linked list bookshelf. Books can be inserted and removed. Books must be inserted in the right order. Now, that means we need to know and have a clear definition of what the order is. So I think what we just said it would be by order is by genre first, then title. Sound good? And that order must always be contained. So I guess we just want two functions, or actually probably three functions. Insert book, remove book, print bookshelf. That should do it for now. I'll point out, actually, this is stuff you'll learn more in data structures and algorithms. But when you have data structures that need to be ordered, there's two major approaches. Anyone know what they are?
Linear regression? Linear regression?
Don't know what. No, sorry. I don't know what linear regression. No, I'm talking anyway. Sorry. What I mean is you can sort when you insert. So anytime you insert a book, you put it in the right place, or you can put it on the end, maybe, and then every say 20 minutes you sort the shelf. So depending on how frequently, because sorting can be kind of expensive computationally, because you got to go through every book and make sure it's in the right spot. So sometimes if you're inserting really rapidly, it's cheaper to insert just at the end. Like think about a library, right? Like sometimes people are going to come into your library and put books in the wrong bookshelf. You can't have someone watching every single time someone puts a book in to make sure that they put it in the right spot. That would be too expensive. So once a week, you go through the bookshelf and you fix up the bookshelf. So the same thing happens in data structures. But we'll keep it simple, and we'll just do that when you insert it, it has to be inserted in the right spot, which means we'll be basically sorting every time there's an insert. All right, so I probably would say that the best place to start is with printing the bookshelf because it's simple. We can make sure it's all working. And actually, we need a way to build the bookshelf from the beginning. So should we start with building the bookshelf, which means we need an insert function first, actually. So actually what I'm going to do, so there's a few helper functions we'll write. All right, these are just the three that we want to build, but we'll need to do some extra stuff. The first thing I'm going to build is, and you know, people were telling me that like when I scroll too quickly, it gets really annoying. What's the, can anyone remember, what's the VS Code command to create a foldable block? You type it in VS Code. Is that going to do it? Oh God, here we go. Sorry. Why don't I have it? Create folding range. Huh, cool. Cool. So it's there, but I've just hidden it away. Thank you. I'm going to just give him a little like, and then we'll move on. All right. So that I'm just trying to stop us from scrolling. And remember, go to the, if you want to see all the source code, because my screen's only so big, go to the website. It's all live, right? Do I need to show you guys? Go to lecture code, and you can find it all here, live, unfolded. Close this. Oh, you know what? I might keep that in case I need something. All right, so we need, what I'm going to do first is a create book function. So not a node or anything like this, but an actual book that we can use in our create node function. And now I'm going to need to peek into our book here. So we've got title, pages. Let's get rid of ISBN just because we're not going to use it. We can use pages for now. And category. All right, so should we have the function read from user input? Or is that, no, that's going to be annoying, isn't it? That's going to be annoying. So let's go. What's the name of the enum? Category. Bit of a long title, but that's okay. Struct book New book. Is it not a book? Struct book. What's wrong with, what am I doing wrong? Yeah, I just want to create a book. Why aren't I getting... Something's wrong with my IntelliSense. Is something wrong? Semicolon, semicolon. I mean, other than not being able to type. Why don't we try compile it? Something is wrong. For sure. Oh, because it's not auto-completing. Maybe not. Maybe it's just... You know, how can I write code without my... Weird. All right. So, no, what am I doing there? That should be just pages. The title should be... Now, how do we assign a string? Remember, we can't do this, right? That doesn't work. Not fputs. That's to read. That's to print a string. String copy. Who said that? Good job. Do we need to include string.h? All right, very good. So what we do is strcpy into the new book title, and we're copying over title. That looks good to me. So we set pages, blah, 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 and then the genre, new book dot genre is equal to genre. That we can just assign. And then we return the new book. All right, in main, we can call it something is very wrong. I don't know what is going wrong here, but struct new book equals create book. We can give it a string. Anyone got a good book? Oh yeah, clean code. Thank you. What genre would that be? Horror. Very good. I think it was like 200 pages. All right. Let's create a print book function just to make sure everything's working. So void print book struct book. Right. I know we're going pretty fast here, but this is sort of the stuff we've done before a few times. So you can just watch the video if you need to look at that. All right. So fputs the book to print. Oh, there you go. It's working now. I don't know what's going on. Title to stand it out. Is that right? Thank you. Something's really slow here. I got to figure out what it is. Now what's wrong? Yeah, I was fine. Thank you. It's okay, Tim. Minus $10 from your weekly salary. We print the book. Now we got to print the genre, which is a little bit annoying in C, but we got to say if the book to print dot genre is equal to horror. In fact, we might need to do a little new line there. We can add the other genres later as we go. Does that sound good? I can't remember. Does it give a new line automatically? Fput? They would both do the same, don't they? Okay, I believe you, but I'm going to leave it. Because it puts, you don't put standard out. Yeah. Which is fine. Okay, so we do that, and let's just not worry about the pages for this point. So we do that, and then we say print book, and we print the new book that we just created there. And let's just see if everything's hooking up correctly. So we've not done anything with the linked list here. Okay, clearly not. What is this saying? I've never seen this warning. Tim? John? Angela? Sizer. Yeah, true. No. Line 49, referencing argument 1. Can I not give it a string literal? Why not? So I got to make a variable which is a string. Really? Oh, what if I... Ugh. Okay. What does this say here? All right, fine. I guess I can do that. Is this what we're saying? Really? I don't remember this, but sure. Now what's going wrong here? Okay. Something's just really slow. All right. I guess we were right. And we get clean code horror. Why don't we... Can we do something fancy like print a little border for the book? Or is that... Am I going to waste too much time doing this? Who's gonna... Now I want to do it. Fine, we'll do it later. All right. Okay, so we can print a book. Clean code. In fact, why don't we not do that actually? And then say like this. I think it's better. Because then we can sort of chain them up a bit better. All right, so we've created a way to create a book. We can print a book. Now we need to create a node because all of this needs to go onto the heap. So it's going to be a struct node new node. Oh, that was loud. Struct node, new node. That's right. We pass in a book. And we can pass in next, right? All right. So I guess we're assuming that the struct is already made here and it gets passed in. So we need to say struct node I've done it again there. We called it data, right? I think that's fine. I don't know what's going on. Okay, so we have a function that's called create node. It returns back a pointer to the heap on where that node is going to be created. In that node, there's going to be, so we malloc the heap with enough data to store a struct node. In that node, there's going to be data. Data is what? Data is a struct, that's right, here, which is a book. So data is the book. And keep in mind, right, that data is not a pointer to data, it is a book. So in that malloc call, there will be enough memory to store the book itself. So 50 bytes for the title, 8 bytes for the int, and however many, I guess 8 bytes for the category, as well as a pointer to next. So we malloc all of that. We've already passed in the data, so we just assign that. And we assign the next pointer. Any questions on create node? Cool. All right, what do we need to do next? Probably hook up a few books and print all the books.
We also don't need to create malloc, like create the memory.
We can have a free all books maybe function. I think that would be the nice way to do it. I guess we can do that now. That's not a bad idea. So remember we spoke about memory leaks last lecture. Memory leaks is this idea that when you malloc memory on the heap, you're responsible for freeing it. And in order to free it, because we have a linked list here, we need to traverse through each node and call free passing in that node. And I think if we look at last week's code, what we did at the end of the program in main, we just looped through there. We looped through our linked list and we just called free to it every time. But what we can do is convert, basically, decompose this into a function called free all books or free all nodes. We loop through and call free, and that means that there won't be a memory leak detected. And so certain labs and stages in the assignment check for memory leaks. The big asterisk here is that freeing at the end of your program is kind of, well, I wouldn't say unimportant, but it's less important because your program's ending, so it's about to free all the memory anyway. But what's useful about it, Does anyone know why it's useful then? It's just so that we can check for memory leaks that were introduced later. Because if we free it, we'll know from leak check that there's no memory leak. So if we introduce another memory leak, we can actually check it. So it is good to just clear it and get into good habits. Oh, but this requires this remove at tail function. So let's do that at the end when we've got more functions for removing stuff. But it's a really good idea to mark that down. Maybe another thing you can do when you're writing bigger programs like this is I keep like a to-do list going. Sometimes it's easy if you get stuck in a problem and you get really happy when you solve it, you forget you've got other things to do. So we can write a little note down here. Don't forget to free all books. So that's really nice. Okay, so what did I say we needed to do? We needed to print all the books. So we have a way to print a book, but we want a way to print the shelf. It needs a struct node, to print. That's all it needs. So we need to print in the head node or the first book or the shelf itself. Oh, that rhymed. Then we need to loop through each book, traverse through each book and print each one. So let's go back to our old code here for print linked list. Why don't we just copy it? Otherwise we'll be here a little bit forever. So while that really formats quite slowly, we create a pointer to the current, a pointer called current, which points to the first book in the bookshelf. While that book is not null, we loop through and we print the book. Now, instead of printing an integer, we need to print what? We call print book. That's right. Because the data we're storing is a book. And the nice thing is we've already created a function which can print a book to the terminal. So here we're just going to call print book. And what are we going to pass in? Do you know? Do you want to yell it? Yeah. You do know. Current, tell me what to type. So what is current? Let's think about it. What is current right now? I'm going to shut the door while you guys think of an answer. Come on, guys. It's declared right there on line 46. What is the data type of current? No, what's the data type of current? It's not a struct node. It's a pointer to a struct node. Okay, good. So if it's a pointer to a struct node, and inside of node there's a book, what do we need to do to the pointer? Dereference it. How do we dereference? An arrow. Yeah, we use the arrow. And what are we dereferencing out of the node? Data. I think it was called data. Who said that? Good. So let's check. A node, yeah, the book is called data. It's probably not a nice name, but whatever. The book is called data, and data is a book. So we're passing a book to print book. Doesn't that sound right? And we don't forget the semicolon. We can leave that. All right, should we test that? Is this making sense? You guys are quiet, but I don't know if it's the Monday effect or if we've gone a bit too fast. Bit of both, yeah, probably. All right, doesn't matter. We're printing each element. Each element is a node. A node contains a book. We have to dereference that node, get the book out, pass it to print book, and we'll print the book. All right, so there's create node. I'm going to create a function here called void create starter shelf. Because we're going to need to do this a few times. Let's just do 3 books to start with. All right, what are some other books? Whoops, that's not what I want to do. Anyone read anything good recently? Crime and Punishment. Yeah, that's what happens when you don't do MyExperience. I don't know what you would call that. I guess crime. All right, another book. Anyone else read anything good recently? Narnia. Narnia. Oh, you could say Jake's PhD thesis. No. That's right. It's not a title. All right, we've got a book nerd at the back. What's it called? Well, The Lion. Is that right? The what? Wait, what is the title? I just can't spell. So they're creating the 3 books, but that's just the book structs. Also, we need to... That needs to be 2, let's say 3. Really, we should have just maybe... Anyway. Now we need to create the nodes. So which book do we want to put first in the shelf? Sorry? Clean code, yeah, the dusty left that we don't pick it up. All right, so create node. It needs the book, so we want to go back to front. So what? So we. Oh, hey, Ravine. So which book do we want to put on the far right? Maybe Narnia. And it's going to point to null. And I got to create some pointers here. Then book 2. And then book 1. No, that's just new. Sorry, new book. New book. Struct node shelf equals null. We can do that, and then we can say that shelf equals that. And that needs to return a struct node pointer to create starter shelf. Is that looking good? Why is it what? Oh, what is it? Fantasy. I added fantasy. Guys, you're caring about the wrong thing. Excuse me, Jake. Okay, so that's going to create that. We just need to call that here. I did create a book print shelf, right? Yeah. All right, is this going to work? No, come on, no syntax errors. He's a genius. Okay, not very good. I think that's just a printing issue, right? Great book, The Lion, the Witch, and the Wardrobe Null. Really recommend it. Print book here. Whoops. Print book prints the title. Oh, of course. Yeah. I knew that would come back to bite me. What else? What is the other one? Horror. We did horror, fantasy, comedy. Oh, comedy and crime. Oh my God, I'm lost. You know, for any of you who are like, how does this guy have a job writing code? Try it on this resolution with one monitor. It's a bloody nightmare. All right. Also, I'm just not that good at writing code, maybe. Crime? Okay, that's better. That's better. I think we want a space before them. Yes. God. All right. And let's actually do printf Jake's amazing bookshelf. Oh, that's awesome. That needs to go in the print bookshelf function. Oh, why is it so slow? Here. Let's do 2 new lines. All right, let's leave it there for a second. Let's do a lecture break for, do you have time, Raveen? Can you wait 5 minutes before you start? Okay, let's do 10-minute lecture break, and then in the meantime, Raveen will get set up. He's gonna do some ICPC stuff. I already introduced you. They already know who you are. All right, you don't. Yeah, well, you came in late because you're talking about astrophysics. All right, I'll see you in 5 minutes.
working?
Yep, that
Cool.
was already on. So they can hear you online when
Yep.
they switch, so don't say anything.
Yeah. Best behavior, don't worry. Hi. How are you doing? Yeah. Cool. How we sounding? Loud and clear? All right, thank you. Yeah. Oh, right, as in not the lecture one. Yep. Sorry?
Oh no, just saying it's cool you what we're talking about.
Yeah. Time to see my very rusty C, right? All right. Cool. I guess we will get started. Has it been about time? Is the lecture mic off still? Really? Wait. Oh. Nope. Try now? Is that okay? Yeah. It's like I really don't like this mic because it's so directional. Like if it's turned inside, then you can't hear anything. Anyway, we'll manage. If this starts playing up, please let me know. Anyway, cool. We look good. Okay. Hello everyone. My name is Raveen. I'm a lecturer here at CSC. Some of you may have seen me, but most likely not because you're fairly early on. So I teach the algorithms course, which is COMP1511 or 3821, and the cross-listed postgrad one. And I also teach a competitive programming course, COMP4128 Programming Challenges. However, I'm here to talk to you about the other hat that I wear, which is convening programming competitions. So in particular, I'm here to promote the South Pacific ICPC Preliminary Contest. Some of you may have heard of ICPC before. Does anyone know what ICPC is? Cool. All right, that's great. Means that this is more impactful. ICPC is the International Collegiate Programming Contest. It is the largest programming competition in the world. It is a competition for universities. So strictly university students take part in this. And every year we have between 50 and 60,000 students from more than 100 countries that take part. The structure of this competition is that it's run first on a local / regional level, and then the best teams filter up through to kind of super regional qualifying, and then eventually the world finals, where teams from all over the world come to one place for a week of programming. Which, look, you're in the right place to not find that to be awful. All right. So what we have coming up next month is the South Pacific's first round of qualifying, which is the preliminary contest. It's held on Saturday the 31st of August. Right? And the South Pacific here means Australia, New Zealand, and change. So we may have some teams from elsewhere across the Pacific as well, but largely Australia and New Zealand. And UNSW, we host a site for this with basically UNSW students. We have a couple of hundred students take part in this every year, but we hope to see many of you there next month. So you'll notice also that this is a joint event between the school and a student society, CPM-SOC. That's the Competitive Programming and Maths Society. We have a lovely group of students who are very motivated to grow the community and make all these programming competitions a fun experience for everyone. So please do check that out. You are welcome to join that, and I recommend it. They run not only these events, but also workshops to teach you new stuff, as well as revision sessions for some courses. So the way that this competition is organized is in 2 levels. There is a level A for experienced competitors who are trying to qualify further to the regional finals and hopefully the world finals. But there's also a level B for beginners who where we assume no prior experience in programming competitions. So most of the problems in level B are perfectly accessible to you with just the knowledge that you've seen from this course, COMP1511. There are some problems that are that use concepts from later courses, such as the data structures that you'll see in the next course, COMP2521, and occasionally something from the algorithms course. But by and large, most questions are programming exercises first and foremost in level B, and it's only in level A that you see the most sophisticated algorithms knowledge being used. So all are welcome in level B, and I expect that most of you will have plenty to do in level B. If you have prior experience, for example, in informatics Olympiad from high school, then you can consider going for level A instead. Free stuff. Do I have your attention now? If you like the t-shirt I'm wearing, register soon. Register by the 31st of July, you get a free t-shirt. There is also free lunch on the day, and if you are doing my course, then you get a couple of bonus marks for that course, but that's later down the line. Hopefully next year we hope to see many of you take that course. So ICPC is a team contest. What you may have experienced already in your labs and assignments and so on, to the extent that it's allowed, is that solving these problems together is easier and more fun. And the same is true for ICPC. I know how frustrating it is. We all know how frustrating it is to try to solve a problem and bash your head against it, not really knowing how to make progress. And sometimes having a friend or two with you is what makes the difference. And so, yeah, ICPC is a team of 3, but using a single computer. So it is fully intended, and it is almost required that you work together. Yeah. If you have yourself and 2 friends who want to do this competition, fantastic. Register, happy days. But I know that this is not always the easiest to organize for everyone. So if you sign up as an individual or with just one other friend, then I will make a team for you with other people who who sign up as individuals or pairs. So that is a good way to make friends, because you're stuck with them for 5 hours. So you'll either be friends or be the opposite of friends by the end of it. So yeah, I hope the problems are interesting and challenging in a fun way, and it is nice to, I hope this course and certainly the teaching team will have instilled in you a desire to solve problems and to use your skills for programming. And this is a great opportunity to put those skills to work in a fun and fairly low stakes environment where marks and stuff are not hanging over your head. Yeah. And we go out of our way to make it a fun event for everyone involved, including things like the flags that I'll show you in a sec. So, sorry, things lagged. So yeah, this is how it might look. You're huddled around the computer together, trying to get the last problem out in the last little bit of time. And you can see here that this team has already solved 4 problems, and they have 4 different colored flags to represent that. Yeah. So yes, it is held at the CSE labs in basically all the labs. Yes. Yes, please. Good question. Sit tight. Give me 30 seconds. All right. Here's something to aspire to. This is our team who won the regional finals last year. They solved, I think this is the first time they didn't solve every problem, but they solved every problem in several previous contests. They're very good. They are traveling in September to Astana in Kazakhstan to represent UNSW at the World Finals. So yes, some goals to have in the long run. How to register, as you've asked. So the contest is on the 31st of August. That is between term 2 and term 3. So hopefully a bit of downtime for you, a chance to put your skills from this course to work when things are a little bit quieter. Scan the QR code, fill in the form. It is 1 entry per team for the form. You don't need to all sign up individually. It will ask you for your individual names and ZIDs and a couple of other things that we need to know, like can you eat everything that we might give you. Yeah, if you are actually unable to make it to campus, then there is a remote option, but we ask that everyone come inside if they possibly can. So yes, follow the instructions that are at the top of the form in case you want to sign up remotely. Come in person if it's at all possible. And I, Raveen, am your contact point if you have any questions about all of this. So that's my email address. Send me an email. I will get back to you. Yes.
Sign up with a friend from, let's say, another university in Australia.
Unfortunately, that's not possible. It's the competition rules say that every team has to be representing a university, whether you're like beginners or whether you're trying to get to the world finals, because there is like that progression aspect to it. So unfortunately, no. But tell them to take part and find some friends at their university, and yeah, go up against each other, see how you do, right? So yes, sorry to disappoint. Okay, any questions about what the competition is and process and registration if you have them? Please feel free to ask those now. Otherwise, I'll run you through an example problem from last year's problem set. Okay, online good? Cool. Okay, so these are the actual problems that were used in last year's Level B contest. And I wanted to talk to you about problem C. So I'll run you through roughly how a problem like how one of these ICPC problem looks, and we'll try to solve the problem together. All right, so in this set there were 12 problems. This is problem C, called capturing bishops. You'll see up the top here it says time limit 1 second. What this means is your program will be run on many test cases, many input files, and your program needs to produce the answer within 1 second on each and every input file separately. Right? So it'll be tested on input 1, and it needs to produce output 1 within 1 second of running time. And so on for these sample inputs that you see, as well as some secret inputs that are not disclosed to you during the contest. All right, let's have a read of the problem. We'll see whether the time limit is a real thing that we have to think about later or not. Hopefully, as you might have experienced, most of your programs run very fast, hopefully much faster than 1 second. So hopefully not something that we have to really worry about. Okay, so some of you may be familiar with the game of chess. Good news is you don't need to know very much about the game to understand the problem. We have an 8x8 grid. And while in the full game of chess there are many types of pieces, in this game we are only considered with the piece called the bishop, which moves in diagonals in all 4 diagonal directions. All right. So in a full game of chess there are restrictions on like different kinds of bishops, like you can have each side has the same kind of pieces and so on. We're not thinking about any of that. We just have a bunch of the same type of piece scattered somewhere across the board, and it's going to be given to us what positions they're in. Okay, this piece moves diagonally, so the bishop that's highlighted in the red square there can move diagonally 1 step to the northeast, if you like, or 2 steps, but it can't move 3 steps because there's another piece in the way blocking it, right? It can also move southeast 1 or 2 steps, and it can move northwest or southwest 1 step. If it goes any further, it would go off the edge of the board. All right. Cool. So a cell on the board is said to be vulnerable if it is occupied by a bishop, or if there's some bishop that can get there within just 1 move. All right. So we can see here that all the circled squares are vulnerable because they can be reached by the bishop highlighted in red. Other vulnerable squares include the 3 squares that are occupied by the bishops themselves, and all the places that the other 2 bishops can move to in a single step. All right. So the question is, given the locations of the bishops in this input format, we need to work out the number of vulnerable squares, the number of cells that are either occupied or can be moved to by a bishop in just 1 move. All right. Now, just like you have seen in your assignments and so on, I think, you are given some test cases, but then there are also other test cases that are kept secret from you that conform to a given format, right? This is how 1511 assignments are still configured. Yeah, perfect. So every input file that you'll be given has this format. It has 8 lines describing the board. Those are the rows of the board. And within each row, there's 8 cells, right? So it's basically just depicted using ASCII art. Dots mean a square that does not have a bishop. Capital B means a square that does have a bishop. Right, and the output format is you simply print the number of vulnerable squares, and that's all. Okay. So let's have a look. Sample input 2, you might recognize, is exactly the diagram that was shown. Yeah. So I don't have a good way of depicting the rest of the vulnerable squares, but if you believe me, there are 16 vulnerable squares in this input. Okay. You can count it yourself if you want to make sure. If you had just a single bishop somewhere near the middle of the board, it turns out there are 12 vulnerable squares from there because it is occupying one square and it has 11 possible moves when you consider the 4 different directions. And then there's a third example given to you where bishops are all along the top row. They cover most of the board because if you consider the southwest and southeast diagonals, most of the squares are reachable, but there are some squares that you're not going to be able to reach. What squares in this grid will not be reached by any bishops? Bottom left. So bottom left corner? Are we sure? Bottom right? Neither of them. Bottom middle is the way. If you're at the bottom left square, you can actually be reached because you take the very last bishop and take it all the way down the long diagonal and will reach the bottom left square. Yeah, it's a square board, so something from the top right can go exactly along the diagonal to the bottom left, and vice versa. If you're in the top left, then going all the way down the diagonal gets you to the bottom right, so those are both reachable. However, something that's in the middle of the bottom row, none of these bishops are going to get you there, right? If I think of all the southeast kind of moves, that basically makes a triangle of reachable squares. The southwest reachable moves also make a triangle, and those triangles overlap in part, about half the triangle is common, but then there's the last kind of quadrant down the bottom, which is not reachable by either the sweeping left or sweeping right. Yeah? Cool. So the question is, how many of these squares are reachable? Notice, by the way, we don't care whether the square is reachable like in several ways or not, just whether it's reachable or not is all we care about. Okay. Have we understood the problem? Or rather, if you have any questions to clarify the problem, now's the time. Cool. So the way that these problems always work is you're given the input format and the output format, and your job is to write a program which, when it gets the input on the standard in, then it prints the output to standard out. Okay, so exactly like so no reading from files or writing to files. Yeah, like most of the exercises that you've done. Right. Of course, you don't know exactly what the grid contents will be. You can't assume that it's one of the 3 that we've been given. It can be really anything. Okay. So how are we going to do this? Let's give it a go. I have one that I prepared earlier if we get stuck, but we're going to try our best to do it live. What? Oh, okay, that's not great. Just a second. It's complaining because it's on my USB and it's saying it's read only. Yeah. I think I got it. Yeah. Sorry, I'm not a Mac user. At least, yep. So just deselect and. Okay,
Yeah.
cool, that worked.
And then you just want to open that in VS Code?
Yep.
Oh.
Ah, drag works. Nice. Cool. Thank you very much. Okay, let's try that again.
PDF extension again, but yeah, again.
That works. Okay, so how are we doing this? some libraries that we might need, we're certainly going to need the IO library, and we'll leave it there for now. If we need more, we'll add more, right? As a general rule, we'll try and do things in like static memory as much as we can. Keep things simple. Malloc and stuff are usually not necessary. So I think the first step with all of these is you are given some information in the input file. You need to work out how to represent that within the logic of your program, right? So you need your program to read that input and represent it in a way that allows you to work with it, to manipulate it as necessary. Yeah. So how would you like to organize the board, the information that's given to you in the input file, in your code? 2D array. A 2D array is very good. So it's going to be a 2D array of what? Ah, right. What are okay? Enums are not. So I use C++ more than anything, but
Ints with labels, but it's
sure. Okay, I'm going to use ints only because I don't. I'm not experienced with this. I had to relearn some C for this demo. But if yeah, enums are presumably doing basically the same thing as what I'm about to do. Okay, so okay, I'm actually going to use the characters themselves, the exact characters that were in the board representation, but you're most welcome to recast this to a 2D array of enums if you like. That's fine, that's equivalent, just as good. So yeah, we would like the board to be represented as some 2D array, and of what size? 8 by 8. Yeah, so let's.
good C programmer. Making constant, very good.
This is definitely what I would do in a real programming contest. No, it's not. What?
How you would write it.
No. It's not a good idea. What? So in programming contests, you have there is a time limit for the execution of your program, but separately from that, there is a duration of the contest. There is limited time to solve all these problems, and implementation is a thing that you try to do quickly, get off the keyboard and let someone else work on a different problem, right? So we take lots of shortcuts and throw out the style guide. Yeah, which is it's good when you're mature enough to handle it and to read it, but certainly has its drawbacks. So we're going to do things the right way for today. So I'm going to make 8 rows, and because each row of my 2D array is a string, I'm going to reserve 1 extra spot for the null terminator of the string. All right. I'm not sure whether you actually have to do this or not, but this is a good question. Do you? Remember, in C, a 2D array is basically an array of 1D arrays, right? So likewise, a 2D array of characters is a 1D array of strings. Strings have null terminators. Arrays don't need to have null terminators. Yeah? Yes, please. I'm not sure. We don't? Okay, fantastic. I was going to read every row as a string. Okay, cool.
Strings, they're just state representation.
Cool. Okay, then that's fine. Is it helpful if I ever want to print the rows?
No.
Okay.
It depends if you print by character.
Yeah. Oh, if you just yeah.
That you'd be going character by character.
Yeah. I mean, you can. Yeah.
So if
Yeah.
you actually just want to pass the whole array.
Sure. Let's go with it. Well, no. As in, if we don't need it, then fantastic. Okay. Cool. If it turns out that we do need it, we'll throw it in later. We'll hope for the best. All right. Cool. Okay. Thank you. Again, this is my rustiness showing up. All right. Cool. So this is where we're going to record what the board state is. Now we have to actually read it. Yeah. So there are really 2 alternatives here. We could either try to grab each character of the input one by one, but then we have to deal with the new lines from one row to the next and so on. an easier way to do this is to grab it row by row. Yeah, it's already organized into rows, and that conforms with how C represents arrays, that the entire first row is the entire contents of the first entry of our outer array in the 2D array. Yeah. So what I will want to do is, for the row index from 0 up to board size exclusive, again, at this point, I could go and step through each individual cell to grab the content, to grab whether it's a dot or a B, but I'm just going to read the entire string. So I'm going to scan that string, and I'm going to save that into board of row, which is itself a pointer to the start of that string. So it's going to grab the entire contents, and if I've done everything correctly, jam it into that row of the array. All right. Yeah? Any concerns? This is... Do we? I'm not sure. Yeah, it feels like a C thing to need it, but we can. Let's see what happens. All right. Yeah. So we're scanning 8 times, and the thing that we're scanning is a row of 8, is a string of length 8, excluding the null terminator. Do we need to reserve a null terminator, like a space for the null terminator in the destination that it's going to? Sure. That probably works. You're going to have to run me through the syntax for that. Okay. Cool. Let's just do this. One nice thing about this is, if your program runs within time limit and memory limit technically, but this is basically never a concern, then it doesn't really matter whether you were perfectly efficient or not. So if you made this board 10 by 10 instead, works perfectly fine. If you made it 100 by 100, it's still fine. As long as you didn't try to scan more input than there actually is. Yeah. So you can put this in a giant array for all I care. All right, let's make sure that we actually did this correctly, because as you can see, we are all unsure if it exactly worked. Let's try and just echo the board out to the terminal, and we'll do that by printing, and we'll print cell by cell just to exhibit how this is going to go. So let's do the same for every row from 0 up to n-1. For every column of that row, what we're going to do is just print out exactly the value that's at that cell. So I'm going to print a single character, which will be board row col. And then at the end of that line, to make sure that I don't just print all the rows in one big long sequence, I'm going to print a new line character as well. Okay. Let's give this a go. Let's see if it does what we expect it to do. Jake, how do I get a terminal for you?
Command tilde.
Command, oh, tilde, okay. Not backtick? Where?
Same key.
Yeah. Oh, as in, do you need shift or not?
Sorry, control tilde.
Control, right. Thank you. Okay. All right, let's give this a go. First, I better get the actual input files. So during the actual contest, they will be provided to you like from a download link, but we are unfortunately going to have to type them ourselves. Or I can use the ones I prepared earlier. I hope you don't mind. All right, so I have these 3 input files. 1.in looks like this, and so on. They are, again, the ASCII art that we saw earlier. Sorry. Yep, no, just Mac things. All right, let's give it a go. So we compiled our executable called bishops. And yes, that is indeed printing exactly the grid that we were given to us. We'll run it on the next one just to make sure. And so That also looks good to me. It's printing all 8 rows. If I wanted to confirm this, I could. Oh, I could store the output of that in a file 2.out. I'll call it 2.out, and I could diff 2.in with 2.out to determine whether there's any differences at all between the two files, and there is no difference. There was no output, so they are identical. So good, we have correctly represented the board. Is diff new?
No, yeah.
Cool.
So are the pipes. But why
Okay. Sorry?
print a row?
Printing a row would be perfectly fine. I was setting up because we are going to do this, like we're going to do nested loops later as well. Yeah, cool. Okay, so this is getting me to what are the contents of every cell. However, this is of course not what we were asked to do in the question. Yeah? What were we asked to do in the question? Find the number of vulnerable squares. How do we propose to actually do this?
We could place on each of the squares the bishop can move out.
Cool. So we can go over all the bishops and drag them in the 4 directions to mark all the squares that they can get to. This is a perfectly viable approach. Yeah.
How do we deal with if the bishops are overlapping in paths?
Overlapping in paths meaning like diagonal crossing at some point, or they're in the
same direction.
Cool. Good question. So yeah, this is a concern. If we kind of add 1 every time a bishop can reach a square, then we might double count because we might have the same bishop, like 2 different bishops marking the same square, or indeed more than 2 bishops. Yeah. So we do need to be careful about that. And we also, so there are a couple of ways around this. One is you can instead of adding 1, you set it to 1. So if another bishop gets to the same square, then it also sets it to 1, so the effect is the same.
Another thing where if a bishop marks a square,
Yep.
you can set that as you can't like enter over there. Like we did something similar to assignment, like we put wall there and there.
Good idea. We have to be a little bit careful though, because if I'm a bishop who marks a square in my northeast path, that shouldn't prevent another bishop crossing its in their northwest path and getting to other squares that are later on. Yeah. So we have to be very, very careful in anticipating these things. Another way around this is to basically stop our iteration where we drag the bishops in each direction. Stop the iteration if you get to another bishop instead of just keeping going all the way. Yeah. But even then, you still have to think about northeast versus southwest, and so setting rather than adding is the way to fix this. However, there is one other way to solve this, which I think simplifies the implementation quite a bit. So far we've been talking about approaches where we go over the grid and for every bishop try dragging it around. Is there another way that we could determine the number of vulnerable squares?
And you could just look at it.
Yeah, but how do you tell the computer to look at it? Yes.
Start at a bishop and then check the squares diagonal to it without moving the bishop.
Sure. Yeah, so we certainly don't want to drag the bishop 1 square and then look again, because that will start opening up like L-shaped paths, yeah? But yes, so we can start iterating from the bishop to the 4 directions. Question off the back? There we go. Yes, this is the way that I'm going to propose that we do it. Instead of asking every bishop who can you reach, I'm going to go to every square, whether it has a bishop or not, and ask, can you be reached by some bishop? In other words, if I go in any of the 4 directions, will I ever see a bishop, right? Because if I ever see a bishop in any of the 4 directions, then I have found a bishop who can reach this square, and therefore this square is vulnerable. Likewise, if I start on a square that has a bishop to begin with, that square is again vulnerable immediately. Yeah. So this is the way that I'm going to propose that we do it. For every single square, go through a test for, is this thing vulnerable or not? So instead of printing the contents of the board, I'm going to have a flag for, is this a vulnerable square or not? Initially, I'm going to say that's 0 for false. And as I do various different tests, there's always going to be the possibility to set it to true, meaning, yes, this is vulnerable. Okay, so what's your first test? What's the easiest thing to check about this square? Is it a bishop? So, how do we test this? If board row col is B, and we need to put that in single quotes, then we would set this to be vulnerable equals 1. Yeah. Otherwise, we can now go and test, is this, hang on, let me just, whoa, gross. Whoa.
You could right click, maybe click format, and it will. Whoop, what is it? No.
Goodness. Okay, I'm just gonna keep it simple, not rely on any editor shortcuts. So now I'm going to check, is there a bishop on any diagonal from here, right? So I'm going to try all 4 diagonals, one after another, and if I ever find a bishop, then happy days, we have marked the square. We will mark the square as vulnerable. Okay, let's try each of the 4 directions, starting with. Actually, I'm going to start with southeast. Thank you. Cool. I'm going to start with southeast for the reason that that's increasing in rows and increasing in columns. Okay? So, which squares am I interested in as I go southeast from row comma col? Right? Right now my index is row col. If I go 1 step southeast, what indices would I be looking at? Row plus 1, col plus 1. Then and so if I continue in this way, I'll be offsetting the row and column index by the same amount until I can do so no more, right? Why would I be, like, when should I stop? Yeah, when you reach the edge of the board. Indeed, even if you see a bishop, there's no harm in continuing onwards. You might be wasting some time, but we'll talk about later whether that's actually important or not. Hint, it's not. All right, so what I can do is start a loop. This loop is going to record the kind of diagonal distance that I've iterated so far. So I'm going to start the distance at what value?
0, 0.
So I don't need 2 loop counters. Like I don't need 2 trackers of the offset because the horizontal and vertical offsets are the same. Yeah. So I can start from 0, and I will keep going so long as this is on the board. Now, there is a subtle thing about this already, but that might be what the question is about. I'll take that in a second. So I'm going to write a helper function later that tells me whether we're on the board or not, right? And again, that helper function is going to return 1 if it is on the board, and therefore we should keep going, 0 if it's no longer on the board, and so we should stop there. And I'm going to increment this, the diagonal distance. Now, one small thing here is I'm actually going to suggest that we change the starting point to 1, because there's no need to check. When dis is 0, row plus dis is just row, col plus dis is just col, so that we have to be checking the square that we started from. We have already checked that square. There's nothing to do, right? There's definitely not a bishop there, because we checked that already. Yep. So this is now starting from 1 step in that diagonal, then 2 steps, then 3 steps, etc., until we get off the board. Yep.
Does that mean you could get rid of that if statement and start at 0?
Yes, that would work too. Yeah. I think the logic is easier to follow this way. Yeah, yeah, cool. Yeah. It's also slightly redundant because we're going to end up doing the same check for all 4 directions. Of course, less lines of code is still true. Yeah. No, I agree. Okay, so so we're going to worry about onboard later, but supposing it is on the board, what do we want to check about this square that is 1 or 2 or 3 diagonally from row comma col? What do I want to know about the square that I'm inspecting right now? Is there a bishop there or not? So if it's a bishop, so if board with that offset row plus dis and col plus dis, if that square is a bishop, then this square has now become vulnerable. It may have already been vulnerable for all I know, but it now is certainly vulnerable. That would also be fine. You could do this, but you would have to record what the original row and col were, because we're going to have to repeat this for the other 3 directions, right? So if you make a temporary row and keep updating that, perfectly fine. But I think this is a slightly cleaner way to implement the same idea. Cool. So this checks whether the cell is a bishop, and if so, then the place that we started is now a vulnerable square. Okay, thank you. Jeez, that went quick. All right. So we're going to need to do this in other directions. I did something really bad. I copy-pasted code. I really do not recommend this, but we're going to have to make it work. Yeah, so the trouble with copy-pasting code is you're going to forget to make all the corrections that you need to make from one part to the next. But we move, as they say. Okay, so if I'm going southwest, then I should be increasing in rows but decreasing in columns. If I'm going northeast, I should be increasing in columns but decreasing in rows. And for northwest, I need to be decreasing in both. Whoop. I swear half my time has been just trying to get my head around how Mac works. No, it's okay. I think I'm close enough now. All right. Cool. So this is going to record whether the square is vulnerable or not. And assuming that we write on board, which we'll do in a minute, this will answer the thing. We need to record not only is this square vulnerable, but we need to tally them up, right? So we need some answer that sits outside all of this from before, which will count how many of these vulnerable squares there were. And if we get to the end of, which loop is it? If I get to the end of this loop and now the cell is vulnerable, then I want to add 1 to the answer. Indeed, I can simply do ans plus equals vul, because if the square is not vulnerable, I'm going to add 0 to the total. If it is vulnerable, I'm going to add 1 to the total. And at the very end, outside both loops, I'm going to print the number of vulnerable squares. Last thing to do is report whether a particular square is vulnerable, is on the board or not. So is it on the board given a row and column index? Here I'm going to say default is yes. So yeah, I'm going to say default is yes. And now I'm going to consider all the ways that it might be violated. So if the row is negative, or the row is too big that it's off the board, or the column is negative, or the column is too big, it's off the board, then I should return false instead, and I'm going to return rut. And if I'm yeah. No. Oh, it's print answer. Thank you. No worries. You're welcome. Let's try this. What have I done? Oh, because I don't have a prototype. Thank you. Yep. Again, we. No, no. No, it's not. What? I am recompiling, and it's not happening. Oh, because it's, yep, okay. Okay, it works with C11. Cool. 12, 16, 52, hey! All right, we got there-ish. All right. Now, incidentally, if you want to have a go at this, challenge for you. How would you do this if the problem said, instead of report how many are vulnerable, print out the board with a B for there's a bishop there already, V for it is like a reachable square, or a dot if it's not a reachable square. All right. Cool. I hope to see you at the contest. No worries. You're welcome.
Thank you, Jay.